Hello and welcome to Chem 130. I am going to be going over the study guide that I gave out for Unit 7. This is the quantitative composition of compound study guide. We're really going to be going over molar mass of compounds, how to convert moles to mass to moles of a single element or compound, and then how to find percent composition of those compounds. So let's get right into it. The first section that I want to go over, so let me zoom this in, was how to find molar mass of a substance. This is a review. We've done this before in class. So I went ahead and did most of the calculations. Now, the units for this grams per mole. You can put it into a stoichiometric problem by putting 1 mole over its molar mass or the molar mass over 1 mole. Or you can just write it 1 mole equals, so like 1 mole of CH2, Cl2 equals the molar mass in grams. Okay? So any one of these three is correct. All right. So essentially, you have to remember how to count atoms. So in number 2, I know I did some of these in class, but I just want to review. In number 2, we have calcium hydroxide, and hydroxide is in parentheses because the charge on calcium is +2. So we need 2 of these hydroxides because they have a -1 charge. So you have to distribute that 2 inside the parentheses. So we take the mass of 1 calcium, 2 oxygens, and 2 hydrogens, and we get 74.10. Okay. If you don't have brackets or parentheses, excuse me, but you have subscripts, then that means you should multiply by that subscript the mass of that individual element. If there was a coefficient in front, so like let's say I had 2 NH4Cl, then that's a coefficient. You would distribute that coefficient to everything in the formula. So something like this, if I had 2 CO2, this would be carbons would be 2 times the mass of carbon, which would give us 24.02, and then 2 times 2 for oxygen, so that would be 4 times 16, which would give us 64. And then you would add those up and you get 88.02 grams per mole. So you have coefficients that you have to distribute. You have subscripts that you have to distribute if there's parentheses. If not, then you just go by the subscripts that are in the formula. So this is 1 subscript of calcium, 1 subscript of carbon, and 3 of oxygen. So that's how I got the masses. Okay. All right, moving on. Let's skip down. Let me zoom this out. I know we did the first one in class, and I just did the second one as an example. But here is where we have a compound, and we're given so many moles of that compound, and we have to convert it into, or we have grams of the compound, and we need to turn it into moles. So I'm going to be using these numbers up here. So 89 grams of NH4Cl over 1. And NH4Cl is 5350 grams per 1 mole of NH4Cl. NH4Cl. When we go to cancel, grams will cancel the top and bottom. That leaves us with the unit that we want. So we multiply across the top. 89 times 1 is the same number. 1 times 53.50 is the same number. This has the mole unit, so I'm going to put that up there. So we're basically just dividing these two numbers. So let me clear this out. So we have 89 divided by 53.50. We get this big, long number. We have to look at our given. It was 2 significant figures. So I'm going to look at 1.6. The 6 next to it is going to round it up. So it's 1.7 mole of NH4Cl. Okay. All right, let's go to the bottom. The bottom is where you're given moles and I want grams. So we have this little mnemonic that we did in class. If you're going from grams to moles, you're going to divide the given by the molar mass. When you have moles, you're given moles and you want to go to grams, you're multiplying the given by the molar mass. Okay, so let's just do that calculation. We have 1.5 mole of NaClO. Moles are on top, so I have to put 1 mole of sodium chlorate on the bottom. And then I'm going to use the molar mass I've already figured. And then if we look, there you go. Moles are canceling, so I have my given times my molar mass divided by 1 times 1, which is the same number. So if you can remember these little mnemonics, you don't really have to write out any of the work. You just got to make sure you have the right molar mass. So 1.5 times 74.44, we get 111.66. We look at our given, it's 2 sig figs. I'm going to look at the first two. One's not going to do anything. So this actually becomes 110 grams of NaClO. Okay. All right, so let's just do the next one. We know we got to multiply by the molar mass, and the molar mass of calcium carbonate is up here, 109 grams. So I'm going to take 0.67, which is what we're given, okay, and then times that by 100.09. And I get 67.0603. Look at my sig figs. I have 2 sig figs. I'm going to look at the 6 and 7. Zero's not going to round it up. So it's just 67 grams of CaCO3. And that would be my final answer. Okay. All right, now down here at the bottom, we have to calculate. Let me zoom this in just a little bit. We have to calculate how many grams of gold, so this is my unknown, contains in this many atoms. So when we have a unit like this, we're going to have to remember to use Avogadro's number. As always, we start by writing the given times 24 atoms of Au over 1. Avogadro's number says that for every 1 mole of a compound or an element, it is 6.022 times 10 to the 23rd atoms for that compound or unit. And if I do that, I get rid of atoms, but I'm at moles. I want grams. So I have to do one more step, because we know 1 mole of any substance is its mass. Now, since it's just an element, we would use the mass off of the periodic table. So 196.97 grams of Au. Now I can cancel moles, and I'm left with grams, which is what I want. All right? So remember your order. Whoops, I'm off camera. Remember your order of operations. You have to do all your multiplication on the top and bottom first, and then divide. Now the bottom is going to be simple because it's just 1 times Avogadro's number times 1. So let's do this top portion first. So let me clear this out. Because I have this times 10, I'm going to put that in parentheses. 2.98 times 10 caret to the 24th. And then I'm going to multiply that by 1, which is the same number. And then, so I'm just going to multiply by this, 196.97. So here is my number. We have this big long number, and then E26. That means times 10 to the 26th power. So now I'm going to hit divide. I'm going to put in parentheses, 6.022 times 10 caret 23rd parentheses. And now we get 974.7103 grams. You go look. Our original base number has 3 significant figures. 974.7 is going to round to 975 grams of Au. And that's my final answer. right, on the next page, we're using these masses up here to calculate going from moles or finding moles from grams. So these are individual elements where I have the grams. So you're just basically taking the given and dividing by the mass on the periodic table. So for number 1, I got 0.0200 moles of sodium. For number 2, I got 0.175 moles of silver. And then for 3, when I rounded, I got 2.48 moles of sulfur. So pause the video if you need to so you can see the work. I'll zoom this in just a little bit. Okay. Let's go to the bottom. This is where we had to calculate percent composition of each element. Now you can see I did one of them in class, and then I did the other 2 right here. So essentially you're taking the mass of what was in the compound and dividing it by the total molar mass, and then multiplying that by 100. So pause the video if you need to see the work on the first 3. I'm going to do the last one and do the shortcut and just take the mass divided by the molar mass times 100 on these to save some time. So we take 39.10 divided by 158.04 times 100, and we get 24.74. So we're going to call that 24.7%. For manganese, we have 54.94 divided by 158.04, the molar mass of the compound, times 100, and we get 34.76. So I'm going to round that to 34.8%. And then oxygen, we had 64 grams divided by the molar mass of the compound times 100, and we get 40.49. So I'm going to round that to 40.5%. Now, if you round all, or if you add all those together, you should get to 100%. Sometimes you'll be over by a little, you'll be under by a little, because we are doing rounding here. And when I add those up, it actually does come out to 100% even. All right, so on the next page, you had to fill in the blank. So pause the video so you could read those and fill them in. For number 8, we're trying to find the empirical formula. So the first step we have to do is to take the masses that are given for each and convert them into moles. This would be moles of each substance. Okay. So we take the mass and divide it by its atomic mass from the periodic table. So we get these numbers. Notice how I did round a little bit. You don't have to put the whole number, okay? Step 2 is to look at the smallest mole number and divide every single one of them by that mole number. So the first one happened to be the smallest mole number. So I went ahead and did those calculations. Obviously, we're going to get 1 if we divide by the same number. For the next one, we got 1.0134, which we can round to 1. But then on the last one, we got 1.4864. We cannot just round that up to 2. That would be 1.5. So what do we do when we have a non-whole number when we calculate by the moles? Well, we have to move on to a step 3. So, step 3 would be, if these are whole numbers, we would just write the formula. Since we can't do step 3, we have to do what's called the multiplier step. So after we divide by the smallest mole number to see what the formula is, if we don't get a whole number, step 3, or 3A, if you can't write the formula, is to do the multiplier step. So you've got to multiply all these numbers by something that's going to get it up to a whole number. So if I multiply by 2, I get 2, 2, and 3. So my formula is Na2, and then this is S2O3. Okay? All right, I hope that helped with empirical formula and molar mass. The other two that